Now we'll move on to sets, working with sets. Okay, so far we have seen about the tuples. Now we'll look into working with sets. Okay, what is a set? A set is a disordered collection with unique elements. Very, very important property of a set. Set cannot have duplicates. Okay, so whenever you're trying to work with set, take care that it doesn't have duplicate, does not support duplicates. Okay, the elements in a set cannot be changed. It is immutable. So what we can remember, set cannot have mutable elements like list, set or dictionaries. Okay, so you cannot have all these elements as elements. Okay, right. A set is mutable, which means the elements can be added, removed or deleted, but you cannot do other manipulations. So the main operations are membership test, eliminating duplicates, and then you can perform mathematical operations like union, intersection, difference and symmetric difference. So we'll see one by one. Okay, so how has a set been created? Like we know, list is created with a square bracket, tuple is created with a parenthesis, and then set is created with a curly braces. Okay, now we have a set, num set, which is named as num set. So you can see the elements are repeated, but when I try to print it, you can see it removes all the duplicates and print the unique values 1, 2, 3, 4, 5. Okay, now we are using, this is a list, we are converting the list to a set. So again it's going to be unique. So we can also create set with using the set function, but we don't have any elements, so it's showing it as set. Now we'll take an example. So before showing you the program, this is how the visualization or the output of your program. So we'll see one by one how it works. First we are creating a set, so that is, you can observe we are printing it. Next we are creating elements inside the set 1, 2, 3, 4, 4, 3. Okay, then we are trying to print it, print S1. When I am trying to print it, what will be the output? 1, 2, 3 and 4. Now as already said, it cannot contain, a set cannot contain a list, a set or a dictionary as an input. So you can observe here a list is a input over here. Okay, so it cannot have an input, so it will throw an error. Okay, now we are trying to print the S2. Okay, then we have S3, 1, 2, 3, 4, 5, 6. So print S3, it's printing. So we are using the set function, you should observe here. We are using the set function. Then we are creating a set F4. So it's going to be printing 1, 2, 3 and 4. Right? So you can see the visualization here. S1 is 1, 2, 3, 4. S3, so since because it is error, I have commented it, so it has not been shown in output. S3, you can see 1, 2, 3, 4, 5, 6 and S4 is 1, 2, 3, 4. This is how the set has been created, and then we're trying to print the type, data type, that is going to be set. You can observe the output over here. Okay. So we can have some or perform some basic operations on set. So add, remove, discard and clear. Add adds an element to the set. Remove removes an element. Carefully you should observe, raises an error if the element is not found. Okay. Discard removes an element if present. No error if not found. So you should remember the difference. Discard does not throw any error. Okay. Clear removes all the elements from the set. So we'll take one example and then we'll understand how the operations are performed. So we are creating one set, that is 1, 2 and 3. So a set is created. Now we can add an element. So always the element is added at the last. So 1, 2, 3, 4. Okay, it's added. Then again we are trying to remove 2. So we are having 2. So remove element 2 is removed, and then we are trying to print it. So it's printing 1, 3 and 4. Now I am trying to use remove on element 5. It's not there, so it's throwing an error. Discard 3. So 3 is there, so it's discarding, and then it's printing, it's having only 1 and 4 as its element. Then I'm writing clear the set dot clear, it cleared, so we have an empty set. Then that's all. So those are the operations. Now we'll talk some advanced set operations. So the advanced set operations are union, intersection, difference and symmetric difference. So you can observe the symbols used for all these operations. So union combines elements from both sets. Intersection, it finds the common elements between the sets. Difference, element in one set but not in the other set. Symmetric difference, elements in either of the set but not both. Okay. So we'll take one more example to understand this. So we have created a set 1 which having 1, 2, 3, 4, and we have created a set 2 that is 3, 4, 5, 6. So first we're trying to print the union. Union, you know, it's going to combine. So it's 1, 2, 3, 4, 5 and 6 is going to be out. Then intersection, common elements in both are 3 and 4. So you can observe here on the right side you have the visualization. Difference, always you can find the difference. So the set is also given here. So 1, 2, 3, 4, 3, 4, 5, 6. So whatever is in set A it is getting printed. Common elements 3 and 4 are ignored. Okay, whatever is present in set A is not should not be present in set B. Symmetric difference. So the common element 3 is ignored. So remaining 1, 2, 5 and 6 is printed. 4 is also a common element. So that's also ignored. Now we'll talk about one more advanced set, that is set comparison. We're going to compare and apply all these comparison operators. So A is less than or equal to B. So output is true. Means A is a proper subset of B. So all the elements in A is contained in B. So it's giving true. A is again less than B. Yes, it's always true. Okay, A is a proper set of B. So it is true. Okay, the difference is it was a subset. Now it's a proper set. The second one, A is less than B. B is greater than or equal to A. It's true because B is B the superset of A? Yes, because it has two extra elements. Now A is greater than B. Is B a proper set? No, it's not a proper set of A because it always have an extra element. So it's false. Now we'll talk about another set, that is the frozen set. Okay, a frozen set is an immutable version of a set. So you can perform some addition, you can remove and you can update the elements inside the set, but elements cannot be modified here. Okay, we cannot do anything over the frozen set. Okay, here set remains constant. Whenever you wanted to perform or develop an application with data integrity, where you feel data integrity is important, there you can use the frozen set. Also, you can use this as keys in your dictionaries. Okay, so since it is immutable, it is optimized for certain operations. Okay, now we'll take one example to understand the frozen set. So at the top we have created one frozen set. So you created frozen set of, you give the elements inside the set. Okay, so when you try to print it, your output will be 1, 2, 3, 4. So we'll try some mathematical operations over this frozen set. We have two sets A and B, frozen sets. So 1, 2, 3, 3, 4, 5. So you're going to perform. So the output will be A union B is combination of A and B set. So 1, 2, 3, 4, 5. Intersection, the common element, that is 3. 1 and 2, because A minus B, whatever is in A, it will neglect the common, that is the element that is present in B. So output is 1, 2. Symmetric difference, so it's going to remove the common element and print the rest of the elements. So here modifying a frozen set. So when I'm trying to see this sentence or this code, frozen set dot add of 6, what will happen? It will raise an error because in a frozen set you can't do anything. Once you created, it is created. Okay. Okay, so now this is the collective output of all these mathematical operations. Now we can see the frozen set as dictionary keys, because we know that this frozen set is immutable, we cannot change it. So you can see the code here, we have created a dictionary. This is a key and this is the value, and then we are trying to print it. Okay, so you can have the visualization effect. A dictionary is created. Okay, now this is going to be a key and this is going to be your value. So always you can use your frozen set as dictionary keys. Okay. Now finally we'll look upon the difference between set and frozen set. Okay. Set, you can perform some of the operations. It's mutable. Here it's completely immutable. You cannot change anything. So what are the modifications you can make? You can apply add, remove and update. No modifications are allowed. Hashable, no, cannot be used as dictionary key, but this can be used as your dictionary key, that is frozen set. Okay, supports all set of operations. Non-modifying set of operations are supported. It's slightly slower, it's faster. Used when modifications are needed. Used for constant data, wherever you wanted to have data integrity, there you can always use the frozen set. Thank you for listening.